Welcome to the second episode of Prismatic Perspectives. And today, what I'm going to walk you through is going to be a very interesting algorithm. It's the one on Fibonacci series, which we have all studied in college. But then, what is it that is worth exploring or discovering here? The interesting thing in Fibonacci series is that though it seems very simple at the outset, there are complexities associated with performance, algorithm design, algorithm scalability, and also storing the number when the answer becomes big and doesn't fit into just one integer. These are some of the interesting aspects to look at, and they're all covered as part of prismatic perspectives. Now, let's get down to the algorithm, typically in the simplest form. And when we talk about the algorithm in the simplest form, this is exactly what the algorithm looks like. We see that there are at least three different ways of solving it, and the most natural definition is that of recursion, where f of n is f of n minus 1 plus f of n minus 2. And this is fundamental. It solves all problems from first principles, easy to understand, easy to conceptualize, and easy to write the algorithm. But the call stack gets very deep here, which means that in certain operating systems, there could be a limit on the call stack, and we can't get to the number that we really want to compute. The recursion terminates in the middle because of a stack exhaustion problem. You could have other systems where the stack is big, but again, if you keep on doing these operations a large number of times, it degenerates into a binary tree. And if you have a look at the tree, at the end of the day, the number of operations or computations required is very expensive because of the nature of the operations performed and the dependencies involved, right? So by default, any person who starts off will choose the recursion method because it's the easiest thing to do. But once a person has written the recursion method, it's quite intuitive that there is an optimization possible by memorizing or remembering whatever is calculated. And that is the second approach, caching or dynamic programming. So if one chooses caching or dynamic programming, the performance of the algorithm considerably improves and one doesn't have to wait for a long time to get the results. In fact, if you see and try to compute the Fibonacci result for 614, after some time, the original recursion algorithm just seems to suspend and takes a huge amount of time to come out of the recursion graph or recursion tree. But the caching algorithm does very well and it comes out of the caching tree in a deterministic amount of time, especially because of memorizing. And that is a clear indication of the fact that the call stack overhead is significant for recursion. Now, after doing one and two, one intuitively realizes that three is the quickest way to do it. Have a simple loop, build it bottom up, start from zero, start from one, and build up the tree. And this is the quickest and the fastest way to do it. And it seems very simple. And once you have one and two done, three seems to be very simple. And we obviously think why we couldn't do it earlier. That is how the mind progresses or we think about it, right? So now let me also explain what happens in case of each approach. And in fact, the details have been mentioned here, right? What I probably didn't touch upon is the time and space overhead, which is captured here. We need to see that the space overhead is also taken care of. Instead of O of n, we use O of 1 in case of the iterative method. And the time complexity is huge in case of recursion without memorization or optimization or using the cache. So this is how it is, and we essentially see that O of 2 power n is inconvenient, and it's really huge. It's a big number that we are looking at. What I would like to conclude in terms of a summary is that iteration is the most elegant, it's the most clean and the fastest algorithm. Now, what I would also like to do is I would like to um, come back to the original problem statement that we started off with, that is in conjunction with the